13.8 billion years ago, everything that ever was or ever will be exploded into existence from a point smaller than the period at the end of this sentence. But here's what will blow your mind. We're about to journey into the impossible realm before that moment, where nothing was an empty space, where time didn't tick, and where the very concept of existence breaks down completely. We'll explore quantum foam bubbling with virtual particles, infinite multiverses colliding, and mathematical realities that make our universe look tiny. If you're ready to question everything you think you know about reality, hit that like button and subscribe. Prepare yourselves. We begin. Picture the ultimate deadline, the literal end of before and the birth of when. Scientists call it T0, but that innocent label hides the most violent transformation in cosmic history. At this boundary, the very concept of before becomes meaningless because time itself didn't exist yet. Think about that for a second. No ticking clocks, no aging, no sequence of events. Not darkness waiting for light, but the complete absence of duration itself. The mathematics break down here like a computer dividing by zero. Einstein's equations, which describe gravity and spacing with perfect precision everywhere else, simply stop working. They produce infinities and impossible answers. It's as if the universe has a do not enter sign written in the language of physics itself. But here's where it gets truly strange. The moment we're trying to understand isn't just the beginning of our universe. It's the beginning of the very framework that lets beginnings happen. Before this instant, there was no stage for any cosmic drama to unfold on. No dimensions to measure, no space to fill, no time to pass. Imagine trying to describe the color of something that has never reflected light in a place where light itself is impossible. That's what we're attempting when we ask what came before the Big Bang. We're using concepts that only make sense after the moment we're trying to examine. Yet, modern physics suggests something profound was happening in this impossible realm. Quantum mechanics tells us that even in perfect emptiness, energy can briefly flicker into existence and vanish again. These quantum fluctuations happen constantly in the vacuum of space today. But if they could happen in absolute nothingness, then perhaps nothing was never truly nothing at all. The leading theory suggests our entire universe began as one of these quantum fluctuations. But instead of disappearing, it grew in less than a trillionth of a trillionth of a trillionth of a second. This microscopic bubble of energy expanded faster than light itself, creating space as it went. Think of it like a soap bubble forming on the surface of completely still water. Except the water doesn't exist. The surface doesn't exist. And somehow the bubble creates both as it grows. The bubble becomes the entire pond, the entire world, the entire everything. This process called cosmic inflation explains why our universe looks so uniform in every direction. It also explains why space appears flat instead of curved. But it raises an even more mind-bending question that physicists are still wrestling with today. If quantum fluctuations can create one universe from nothing, why would they stop there? The mathematics suggest they wouldn't. They suggest something far more extraordinary than a single cosmic beginning. But what we discover next makes our origin story look simple. When you empty a jar completely, is it really empty? Most people would say yes. But physics reveals something shocking. What we call empty space is actually buzzing with invisible activity. Even in the deepest vacuum between galaxies, where matter is so sparse you might find one atom per cubic meter, space itself remains alive with energy. This isn't the kind of nothing philosophers debate about. This is measurable, detectable, experimentally proven nothingness that refuses to stay nothing. Scientists discovered this when they tried to cool things down to absolute zero and remove every last bit of energy from a system. They found something impossible. The energy never reaches zero. Even at the coldest possible temperature, minus 460 degrees F, quantum fields still vibrate with what physicists call zero-point energy. It's like trying to calm a pot of boiling water. But no matter how much heat you remove, tiny bubbles keep forming and popping at the bottom. These quantum fields fill every cubic inch of space, creating what scientists call the quantum vacuum. Picture an ocean that looks perfectly calm on the surface, but beneath the waves, countless creatures swim in patterns too quick and small for your eyes to catch. The quantum vacuum works the same way, appearing empty while hosting constant creation and destruction at scales smaller than atoms. Here's where it gets weird. These quantum fields can borrow energy from the future to create pairs of particles that pop into existence, dance briefly together, then annihilate and disappear. This happens trillions of times per second in every tiny volume of space around you right now. The borrowed energy gets paid back so quickly that the universe's accounting system never notices the debt. Scientists prove this isn't just theory by measuring the Casimir effect. When you place two metal plates extremely close together in a vacuum, the quantum fields between them have less room to fluctuate than the fields outside. This creates a tiny but measurable force pushing the plates together. Empty space literally exerts pressure. But here's what will make your head spin. If our observable universe came from quantum fluctuations in a vacuum, what was that vacuum sitting in? What provided the quantum fields that could fluctuate in the first place? We're forced to ask whether even deeper layers of nothingness exist. Some physicists propose that mathematics itself might be the foundation beneath everything. Not numbers written on paper, but pure mathematical relationships that exist independently of physical reality. In this view, our universe isn't made of matter and energy, but of mathematical patterns complex enough to experience themselves. Others suggest that consciousness plays a fundamental role in creating reality through observation. Quantum mechanics shows us that particles exist in multiple states simultaneously until something measures them. Could the act of observation by conscious beings actually collapse infinite possibilities into the single reality we experience? These questions push us toward an even stranger possibility about what existed before existence. Right now, particles are appearing and disappearing inside your body. These aren't science fiction special effects. They're virtual particles, and they're fundamental to how reality works at its deepest level. Every second, quadrillions of these ghostly entities flicker into existence throughout your cells, live for impossible fractions of time, then vanish without a trace. Virtual particles sound like make-believe, but they produce real measurable effects. They're responsible for the magnetic properties of electrons, the way light interacts with matter, and even the force that keeps atomic nuclei from flying apart. Without virtual particles, atoms couldn't exist. Chemistry would be impossible, and you wouldn't be here. Think of virtual particles like cosmic credit cards. They'd borrow energy from the quantum vacuum, spend it briefly on existing, then pay it back by disappearing. The shorter their lifetime, the more energy they can borrow. Some virtual particles live for only 10 to the 24th seconds, but during that incomprehensibly brief moment, they can carry enormous amounts of energy. The quantum vacuum isn't empty space waiting to be filled. It's more like a cosmic soup where ingredients constantly dissolve and reform. Virtual photons carry electromagnetic forces between charged particles. Virtual gluons bind quarks together inside protons and neutrons. Virtual particles of every type pop in and out of existence, creating an invisible foundation beneath visible reality. Here's the mind-bending part. These virtual particles can sometimes become real. When enough energy gets pumped into the quantum vacuum, virtual particle pairs can separate before they annihilate each other, becoming permanent additions to reality. This happens around black holes, where intense gravitational fields provide the energy needed for virtual particles to escape their quantum debt. Stephen Hawking discovered that black holes actually evaporate by turning virtual particles real. Near the event horizon, virtual particle pairs get separated by gravity. One particle falls into the black hole while its partner escapes into space as real radiation. The black hole loses energy in this process, slowly shrinking until it completely disappears in a final burst of light. This process suggests something profound about the nature of existence. If virtual particles can become real when given enough energy, and if our entire universe might have started as a quantum fluctuation, then the boundary between real and virtual becomes surprisingly thin. Some physicists propose that our whole universe might still be virtual in some sense, borrowing its energy from an even deeper level of reality that we haven't discovered yet. In this view, everything we call real, from planets to people to galaxies, exists on borrowed time in a cosmic quantum fluctuation that started 13.8 billion years ago. But if virtual particles can create our universe, they might be creating others too. The same quantum vacuum that spawns fleeting virtual particles around us might be spawning entire cosmos in realms we can't detect. The implications of this realization lead us to a possibility that dwarfs even our cosmic beginning. Our universe might be one bubble in an infinite cosmic bath. Right now, as you read these words, countless other versions of you might be reading slightly different versions of this sentence in parallel universes. Some of those universes are nearly identical to ours, differing only in the position of a single electron. Others are so strange that the laws of physics work completely differently. The multiverse theory emerged when physicists realized that quantum fluctuations don't have to stop with creating one universe. If the quantum vacuum could produce our cosmos, it could produce others. In fact, the mathematics suggest it must produce others constantly and endlessly, like soap bubbles forming on the surface of an infinite sea. Each universe would begin with its own Big Bang, expand through its own version of cosmic inflation, and develop its own unique properties. Some might have stronger gravity, making stars burn faster and die younger. Others might have weaker electromagnetic forces, preventing atoms from forming at all. Most would be sterile wastelands where complexity never develops, but a few might harbor forms of life we can't imagine. Picture an eternal cosmic ocean where every possible wave eventually forms. Our universe is just one wave in this ocean. Temporary and unique, but not special. The multiverse doesn't care about our existence any more than the ocean cares about individual drops of water. But here's where it gets truly staggering. Some versions of multiverse theory suggest there are infinite universes, which means every possible variation of reality exists somewhere. There's a universe where dinosaurs never went extinct. There's a universe where gravity repels instead of attracts. There's a universe where you decided to become an astronaut instead of reading this script. These parallel realities aren't science fiction fantasies. They emerge naturally from our best mathematical descriptions of quantum mechanics and cosmic inflation. When you solve the equations that govern the quantum vacuum, infinite universe creation falls out as an inevitable consequence. The implications are breathtaking and terrifying. If infinite universes exist, then every possible tragedy and triumph is happening somewhere right now. Every book that could be written already exists in some universe. Every scientific discovery that could be made has already been made in countless parallel realities. Some physicists push this idea even further, suggesting that the multiverse itself might be just one level in an even grander hierarchy. Perhaps there are infinite multiverses, each containing infinite universes stacked in layers of reality that stretch beyond our ability to comprehend. But if parallel universes exist, they might not stay parallel forever. Quantum mechanics suggests that universes could collide, merge, or influence each other in ways we're just beginning to understand. The cosmic microwave background radiation that fills our sky might contain subtle signatures of collisions with other universes that happened billions of years ago. This possibility points toward an even more radical idea about what existed before our beginning. What if our Big Bang wasn't the beginning, but the latest restart? Imagine a cosmic phoenix that dies in flames every trillion years only to be reborn from its own ashes. Some physicists propose that our universe follows this pattern, cycling through endless rounds of expansion, collapse, and rebirth. In this view, the Big Bang wasn't creation from nothing, but transformation from something that came before. The cyclic universe model suggests that our cosmos expands for billions of years, just as we observe today. But eventually, the expansion slows, stops, and reverses. Gravity wins the ultimate battle, pulling every galaxy, every star, every atom back together in a cosmic collapse called the Big Crunch. But here's the twist. Instead of ending in complete destruction, the Big Crunch becomes a Big Bang. The universe bounces back from maximum compression, erupting into a new cycle of expansion. Time doesn't end during this transition. It continues through what physicists call a cosmic bounce. Think of it like a cosmic trampoline. Our universe falls toward the trampoline surface, accelerating as it approaches maximum density. Then the trampoline's elasticity kicks in, launching the universe back up into a new cycle of expansion. Each bounce creates what looks like a Big Bang from the inside, even though it's really just another oscillation in an eternal rhythm. This model solves several puzzles that plague traditional Big Bang theory. It explains why our universe appears so uniform in temperature and density without requiring the incredibly rapid inflation that standard models demand. It also eliminates the uncomfortable question of what caused the Big Bang, because there was no ultimate beginning, just endless cycles. Recent observations of our universe's accelerating expansion driven by mysterious dark energy seem to rule out a future Big Crunch.